So this dashboard gives a brief overview of some of the energy monitoring dashboard capabilities within the product. This is built with our standard deployment through a web browser. I'm using Chrome today. This allows you to develop and deploy the graphics into a web browser and then publish it as a thin client to users. So they just type in the URL of the server or web address you've developed and be delivered dashboards, of course, through the appropriate security channels within the security system. So this particular dashboard is centered around a hypothetical automotive manufacturing application where we're looking at energy consumption within different systems in the environment. So if we looked at one of the facilities, we can see in this particular application, it's divided into both the office, so more of the building systems, the related, the team that supports the mainline production, and of course the standard production. And then within that, furthermore, there's different subsystems that are individually metered. Again, this is just an example, but to give you an idea of how this might be split out for different systems. So if we wanted to see a breakdown of the production, let's go ahead and click on that. Now here we have the production. This is grouped by the different systems. I also have the ability to filter this view. So I pop out on the side, you can see some of the different things that we'd be typically filtering within the data set. With the model of how we deploy the application, a lot of this data, there's raw data for the energy consumption, the real-time energy consumption for electricity, natural gas, etc. And then there's perhaps metadata that is related to production statistics, days of the week, time of the month, active schedules, perhaps the batch ID of what you're running for a different process at a different time. It could be different shifts during a multi-shift schedule. It could be, if you're looking at a building system, it could be occupancy at the time that the building was consuming X amount of energy. So what we've done in this dashboard is make a lot of that information available to the user. So if I wanted to filter perhaps to just a few months, I could do that here. Maybe if I wanted to only show weekend information, I can swap to this, only see data for the weekends that are coming through. Perhaps I wanted to see data only when they're not actively operating. So as I'm filtering this, it's giving me a narrowed set of data, and then I can drill further and further into that to see the analysis of that at different time intervals. This is one of the ways that we can drill into the raw data. Of course, if I see any individual one, I can click into that to see the specific energy consumption for that filtered time range. Now, some of the other things that we do with this also pertain to, of course, the roll-up. So once we click through to this dashboard, you can see that we're now looking at the summary data just for the two different subsystems, the office and the production environment for the entirety of the facility. All of this is going to be dynamically aggregated, so you don't have to directly configure the roll-up calculations for that. That will happen intrinsically within the data set once you configure the underlying meters for any individual site. Now, some of the other things that we do, let's look at, say, assembly. So we click through to assembly here, and you'll see a few different attributes on this display. Here we're looking at driving goals for energy consumption. So for the different subsystems, we've set it up so that you can define a target production count. This would be the cumulative energy per, in this case, per vehicle that goes through the assembly line, per part produced, or other calculations. Here it's 4.2 kilowatt hours per part. That's the target for the assembly line for this particular system. Now we can see the actual aggregated over the year-to-date time range is 4.6, so they're above their target. If we wanted to drill down into that a bit more, we could see it filtered by time range, so we can see what the median value is over time versus the days of the month. And we can also see over here a data diagram, which we use as a good means of having a cross-section of data. So we have rows and columns representing months of the year as well as days of the month. So as we go through the data set, we can see at any given time, did their energy consumption meet or did it exceed the target for that time. It's very simply color-coded green, red. There could, of course, be other nuances to how it's being configured. So this is the assembly line. If I were to look specifically at the body shop, we'd see a slightly different environment here. So here within the body shop, again, same exact idea and concept of how you're representing the data. In this case, 10.4 is their target for the body shop system. Actual is well under that, so they're meeting their goal. Of course, this is a long-range aggregate of the average performance, so they'll still have individual days where they hit or exceeded their target energy threshold, but you can see it's doing a much better job in aggregate of achieving their goal set forth by the supervisory team. Some of the other aspects that you can use within the system are that there is dynamic reporting. So this dashboard is something that you can interact with in real time as a user. If I wish to, I could use this command over here, this button on the right, which triggers the generation of a report for one of these systems. So if I look at the paint shop and want to get a summary report of its performance, I'll go ahead and click on that, and it executes the report for that paint shop and then provides me the result in a PDF format. So it's a very similar data set that we're using in the real-time dashboard, but here it is in a more portable format that they can share with workers and give as a permanent record for a status report. Has the same information, in fact, some more detailed, nuanced information about the individual metrics, and of course the same raw data as they're building up this data set. This is configured through an Excel interface, so you can configure anything you can think of in Excel and then design it to be published dynamically with the real production data and real energy data fed into that system. Close that. And the last thing I wanted to show on this dashboard was the data validation and editing. So if we click into one of these systems, let's go back to assembly. Here I can click to the raw data analysis. So here in the data analysis, I'm actually seeing on a 15-minute interval all of the raw data that has been logged for the system for the assembly line. And if I look through, I can see the different values over time. Now, there's going to be a lot of data here, so one of the things you can do is, of course, filter and narrow that down. So maybe if I wanted to see only values that exceed a certain threshold. So let's say over 100. Go ahead and apply that filter. Here in this case, we just have a single value that has exceeded the threshold, well over in advance. This could be a situation where there is perhaps a error within the meter collection of the data. This is not uncommon. Many times the preliminary data validation and data cleansing will happen automatically within the data logging and aggregation system. However, if any of the values do get through the system, this still gives you a secondary opportunity for a user to go in and correct values and make modifications to the system if they needed to set a new threshold for those values. Once they do that, they can actually apply it and reload the data. That will rebuild the data models used for all of the dashboards we saw. Second thing to make aware of on this is that we also included a capability for triggering rollovers. Not uncommon thing with energy meters is that if they are serviced or recalibrated, it may reset the total consumption aggregate value for that meter. So to accommodate that, there's an ability within the system to define specific intervals where there was a known servicing by a technician of the meter. That would define, what was the data source, what was the potential rollover value, and what would be the new value to expect at that time after that service was done. This sort of triggered event could, again, cleanse the data to correct for errors and omissions that are created by just normal operations and servicing of the equipment.